And welcome back. And we're onto a topic which actually isn't that difficult, but I know when I teach it, it's often found to be quite hard because we don't go very deep into it and we just sort of show some curves and get you to do some things with curves. So I think it's one of those things that some of you will find really easy, some of you will find really hard because you're not sure what's going on, and then hopefully the point of this video is we can get more of you to feel comfortable with this type of question. The question basically gives you a curve, and you can see, or you should hopefully know. So again, the point of this is not to teach from scratch, but you should hopefully know that the sine curve looks something like this. And what it's saying to you is, what have I done to the original sine curve to turn it into this adjusted sine curve here? And specifically, it wants you to put it in the terms of y equals ax degrees plus b. It's not ax to the power of 0. All right, I'll pause the video, give it a quick go, and then I'll talk you through it. Okay, now I'm going to give you a really quick overview of transformations. Okay, so let's say in general with a transformation, I could write a sine. I'm going to use different letters here so I don't confuse it with a question. So I'll do cx minus d plus the b that I'm giving in the question. It is worth being really clear that you understand what each of these things do. So this one stretches it in the y-axis. In other words, it turns that into that. It makes it, again, well, stretches it in the y-axis, hence the term. The c here squashes it in the y-axis. So it turns what might be that into something which might have a lot more ups and downs, or it might have a much longer up and down. In other words, it changes the period of the equation itself, or the period of the graph. This one shifts it left and right, so it might shift that to the left or to the right, and this one shifts it up and down. Now, for this particular question, I don't have a cx and a d. It tells me already, or it hints heavily in the question what happens. So it tells me that it's sine x plus b. So that's telling me here that I'm stretching it in the y-axis. I'm making it taller and shorter. And this one here tells me that I'm moving it up and down. So the real question is, how much am I moving it? And the way to approach these questions, or a good way of approaching these questions, is to just draw the basic sine graph. So I know the basic sine graph goes through 91, 180, 0, 270 minus 1, and 360, 0. And whilst I don't need to be super accurate, because I'm just doing it to help me understand what's going on, I will then 270 minus 1, I will then sketch these values that look like this. Now, what's nice, and again, I knew this anyway because I didn't have a C term and a B term, is these are in line because I haven't shifted it left or right. I haven't affected the X value. So really all I'm asking is, how far have I stretched it up and down in the Y-axis, and how far have I moved the overall graph up? Well, if you think about the normal sine graph oscillates around 0, whereas this sine graph here appears to oscillate around the point 1/2. So therefore I must have moved the whole graph up by 1/2. So relatively straightforward start. I can see it must be the case that b is 1/2 because I've moved my graph up by 1/2. The next bit's slightly trickier, but it's not terrible. Think about your usual sine graph. Your usual sine graph goes from -1 to 1, which is a change of 2. This sine graph goes from -2.5 to 3.5, so -2.5 to 3.5, which is a change of 6. And 6 is 3 times bigger than 2, so in other words, I must have stretched it by a factor of 3, so therefore A is 3. So the final answer to my question is y is going to be 3 sine x plus 1/2. Not awful when you know what you're doing, and as ever, a nice sketch will often help you get there a little bit quicker. Do like, subscribe to the channel, leave a comment below, I will reply to you, and a few more of these questions will be coming over the next few days. Thanks all.